Group multiplication table is important for 5 marks for your examination. In examination, you should write this table and these 5 different symmetry operations. In examination, you should write this complete table. You should write this complete table, and should write these 5 different symmetry operations. It is C3 plus, C3 minus, sigma V1, sigma V2, and this sigma sigma V3. For examination, you should write this complete table, and with symmetry elements, and these 5 different operations. That is C3 plus, C3 minus, sigma V1, sigma V2, and the last one is sigma V3. This sigma V3. In this video, I will discuss about the simple trick to write group multiplication table of ammonia. The simple trick to write group multiplication table of ammonia. Without any operation, we can write this table. Without any operation, we can write this table that I will explain here. First, you write C3V, that is ammonia. We know that it contains different symmetry elements. That is E, write E here, E, C3 plus, C3 minus, sigma V1, sigma V2, and sigma V3. Write E, C3 plus, C3 minus, sigma V1, sigma V2, and sigma V3. Here also you write same thing. E, C3 plus, C3 minus, sigma V1, sigma V2, and sigma V3. Sigma V3. Okay. Next, I told that E into E is equal to E only. Similarly, E into C3 plus E into anything or anything into E is equal to anything only. Therefore, E into C3 plus only. E into C3 minus only. E into sigma V1, E into sigma V2, E into sigma V3. Hence, you write like this. Next, similarly, C3 plus into E, anything into E is equal to anything only. C3 plus into E, C3 plus, C3 minus into E, C3 minus, sigma V1 into E, sigma V1, sigma V2 into E, sigma V2, sigma V3 into E, sigma V3. I written this portion and this part. I written this part and this part. Next, the remaining boxes I will label it as box number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. We have different 20 boxes. This part I will fill later. The last boxes that I will fill later. I will written here box number 1 to 20. In this, you have to write the different symmetry elements present in the ammonia. Okay, this last part that I will fill later. Okay, this trick includes 3 steps. Step 1. In step 1, you write the different symmetry elements present in the ammonia in this order only. Don't change the order. In step 1, first you write C3 minus, second you write E, third sigma V2, fourth sigma V3, fifth one is sigma V1, the last one, sixth one is C3 plus. In this order only you have to write C3 minus E, sigma V2, sigma V3, sigma V1, C3 plus. Right, box number 1, 2, 3, 4, 5. Don't write 6 here because in 6 E is present. Therefore, write 6 here. The next number is 7 here. 7 here. Step 1. In step 1, first you write the symmetry elements C3 minus E, sigma V2, sigma Next is step 2. Next is step 2. We return C3 minus E sigma V2, sigma V3, sigma V1, C3 plus. Written already. C3 minus E sigma V2 sigma V3 sigma V1 C3 plus. In first step you written box number 1 2 3 4 5 7 6. In step 2, first you write 14 at top, 14 at top, 14 at top. The next number is 15, 15 you write at bottom. In the second step, you write 14 at top, 15 at bottom. The last number is 20 here, therefore write 20 after 14. The last number is, the last box number is 20, therefore write this 20 after 14. After 14, first in second step you write 14 at top, 15 at bottom. The last number is 20, you write 20 after number 14. Next, next is double of 4 is 8, write 8 here. Double of 4 is 8, write 8 here. The next number is 9, write 9 here, and 10 here, 9 here, 10 here. Okay, in the second step we written 14 at top, 15 at bottom. Last number is 20, I written at top only. Next, double of 4 is 8, write 8 here. The next number is 9, 9 and 10 I'll write here, write 9 here and 10 here. It's a second step. Last step is, last step is we all written 1 2 3 4 5 7 6 14 10 8 9 15 20 from in step 1 and step 2. Okay, in step 3, that is final step, see, E and sigma V3 present in 4 boxes. E and sigma V3 present in 4 boxes, whereas the other symmetry elements present in 3 boxes. E and sigma V3 present in 4 boxes, whereas the other symmetry elements present in 3 boxes. See, first here C3 minus present in 3 boxes. We written already 3 numbers 1, 14 and 20, hence it is finished. Next, E is present in 4 boxes. I told E is present in 4 boxes. We return 2 and 16 here. Next, we need 2 more numbers. Subtract this 14 by 1, you will get 13, right? 13 here. Similarly, subtract this 20 by 1, you will get 19, right? 19 here. And we got 4 numbers. It's also finished. Next, sigma V2 present in 3 boxes. We return 2 numbers 3 and 10. We need one more number. Hence, subtract this 13 by 1. You will get 12, right? 12 here. Uh, we got 3 box numbers. It's also finished. Next, sigma V3 present in 4 boxes. Sigma with represent in 4 boxes. Here I will write the numbers starts from 16 to 18 like this. I will write here numbers 16, 17 and 18 here. I will write 16, 17, 18. 16, 17 and 18. See, C3 plus present in 3 boxes. We written here 3 numbers, hence it is finished. Sigma V1 is present in 3 boxes. We written already 3 numbers. It's also finished. Sigma V3 present in 4 boxes. We written here 4, 8 and 17. The remaining number is 11. I will write 11 here. Hence it's also finished. It's also finished. You should remember this box numbers means C3 minus present in box number 1, 14, 20. E is present in box number 2, 6, 13 and 19. Sigma V2 present in 3, 10 and 12. Sigma V3 present in box number 4, 8, 17 and 11. Sigma V1 is present in box number 5, 9 and 16. C3 plus present in box number 7, 15 and 18. So means you should write these symmetry elements in these respective box numbers. By using step 1 and step 2, Step 3, I written the different symmetry elements present in box number 1 to 20. From box number 1 to 20, I written different symmetry elements by using step 1, step 2 and step 3. See, I written here from 1 to 20. I written by using step 1, step 2 and step 3. See, we written here from 1 to 20. Is this part is finished here. The remaining part is this last 5 boxes that I will fill like this. Here we have C3 plus C3 minus E sigma V3 sigma V1. The remaining symmetry element is sigma V2. I will write here sigma V2. The remaining is sigma V2. I will write here. So here C3 minus E C3 plus sigma V2 sigma V3 is present. The remaining symmetry element is sigma V1. That I will write here sigma V1. Okay. Next, here we have sigma V1 sigma V2 sigma V3 E C3 plus. The remaining symmetry element is C3 minus. That I will write here C3 minus. Next one is here we have sigma V2 sigma V3 sigma V1 C3 minus E. uh, the remaining symmetry element is C3 plus. That I will write here. Next, we have sigma V3 sigma V1 sigma V2 C3 plus C3 minus. The remaining symmetry element is E. I will write E here. The remaining portions are filled here. How? See, here we have different symmetry elements. The remaining symmetry elements should write in these boxes. Okay. Means here we have C3 minus E sigma V3 sigma V1. The remaining symmetry element is sigma V2. Right, sigma V2. Here we have other different symmetry elements. The remaining is sigma V1. Right, sigma V1. Here also right. The remaining one is C3 minus. Right, C3 minus. Here write C3 plus. Here E. Means you should compare this the symmetry elements present in the box, different boxes. The remaining symmetry elements should write in these boxes. It's a group multiplication table of ammonia. Without any operation you can write this table. Without any table you can write this table. It's okay. Next, the last part is here. The applications of group theory. Group theory clearly explains the allowed and forbidden electronic transitions in inorganic chemistry. It explains the hybridization of atomic orbitals and also nature of sigma and pi bonding in and tetrahedral and octahedral complexes. Group theory, it is used in IR spectroscopy to predict IR active vibrational modes in a compound or molecule. Next, it's also used to predict vibrational and rotational modes observed in Raman spectroscopy. It is used to determine the physical properties of the molecule or compound. Next, the molecule symmetry provides good information about how the chemical reaction takes place. It's the end of your symmetry and group theory chapter.